is Chinchilla. Welcome to my podcast. An enthusiastic ramble through whatever has taken my interest the past week or so. Expect technology, games, history, travel, geekery, and as always, much more. Greetings, this is Chinchilla Squeaks. This episode has taken me a little bit of time to put together, hence not on my normal weekly schedule. This is actually a roundup of interviews I did with people as part of KubeCon, Kubernetes Conference North America. So this is going to be very tech heavy. I've got quite a few interviews all edited down for brevity a little bit. I think as there's so much to get through, I'll just stop talking. I'll let the interviews begin and I'll talk to you again at the end of the show. Enjoy. First, this is Nick Durkin from Harness, an AI-powered continuous integration and continuous delivery platform. So, Harness. I feel like I have heard about it before, but tell me a little bit more, and then we'll dig into some more details once we've covered the basics.
Sure. Life is continuous delivery as a service. So anything about CI being code to artifact, anything about continuous delivery being artifact, I would say not just artifact to production, but artifact to customer. And so that's really where it got its start. And now we provide a true software delivery platform that enables you to do all this using artificial intelligence and ML. And so taking away all of the tasks that every developer and operations person hates, we want to operate all of that and take all that out from under their burden using artificial intelligence and ML across the board. So whether that's CI, continuous integration, whether it's continuous delivery, whether it's feature flagging, even cloud cost, which I believe is in my opinion, is a true area where we can start shifting left by giving visibility. We want to automate all of that, all the tasks that people hate.
Do they truly hate them though? Sometimes I feel like engineers do actually kind of like messing around with config files.
Oh, messing around with config files is absolutely fine, but babysitting deployments.
Okay.
Name me one DevOps engineer that loves babysitting a deployment. All right? I mean, they might like the free pizza in the war room, but they sure as heck don't like sitting there watching, monitoring tools and sifting through logs. Like that's not the fun part of the job.
So what's the ML part? Let's start with ML because I think that's probably a clearer cut use case. What's the ML part looking to change then?
Sure. So when you think about the way we use ML throughout the entire platform, in the continuous delivery space, we'll talk about it specifically. It's about removing that time frame where you have to verify deployment, whether it be in pre-production, so as you're running that load test and verifying is it actually good, or if it's running in production alone. So whether it's a canary deployment or a blue-green, understanding how it's doing in comparison. So looking at all of the metrics that you care about, APM metrics, your performance metrics, your custom business logic. A lot of our retailers will take a metric, which is what percentage of people put something in a shopping cart, as well as then what happens, what percentage of them actually check out. So your APM might be fine, your logs might be fine, but if that metric's bad, we need to do something about it. And so it's taking and it's actually monitoring that through the deployment and adding context to the deployment, the same way your best engineer would think about it. And if any of those went wrong, they'd start sifting through the logs, and Harness is doing that for you automatically. We're looking at all of the output to understand what normal looks like. So at any point in time, just like your best engineer, they're like, yep, that's fine. Ooh, hey, what's that new one? Why are we seeing that one a ton? And that's what you want to be alerted on. And more importantly, not just alerted, but actually be able to take action. And that's the important piece. So it's understanding what's happening, and then in context, being able to take action. So is that roll you back to back where you were before you started? Or is that, to call the right people? And again, you can choose what happens when you fail.
So is it predominantly on the kind of post-delivery part, or can we also use that ML to change rollouts in the first place? Or I can also see things here like feature flags, etc. Or is it mostly like if a deployment triggers some unusual behavior?
Great question. So it's across the board. If you think, let's start in like a QA environment, right, where I've got that load test, I'm running all those pieces. Well, I should be monitoring it with all those tools at the same time, also monitoring with the logs, and have that same understanding, except instead of comparing like a canary analysis where I compare what's running in production versus the new one, I'm going to compare against the last load test, which was 5 minutes ago, 5 weeks ago, 5 days ago. Right? It doesn't matter when. I'm going to go compare to that last one and make sure we're doing better. So you do it pre, and then ultimately, again, with our feature flagging models, now that's the thing. Ask anybody who releases feature flags, how do they verify it? They're looking at the knock. They're sitting there looking at all the metrics, seeing what the customer's seeing, whoever they lit up the feature flag for. Why? Why not have a system actually understand that, bring that data in, give you the analysis of it, and then only alert you to take action, or for that matter, take action for you automatically because the data is coming in. So again, whether it's during the deployment, whether it's back when it's in QA or staging, whether it's in production, or whether it's a week later and you flipped on a feature flag for a new customer set, verify that, and again, have the machines do that for you so you don't have to, and only be alerted when you need to. With the AI and CI specifically, so in continuous integration, if you think about what people hate there, I don't know. I love the coffee breaks, I guess, but waiting for my builds to actually build because I'm waiting for the tests to run, like it's insane. It's so archaic. If you think about it today, if I changed, say, like a gas cap on your car, like would you go check every single electrical system and every mechanical system on the vehicle if I just changed the gas cap? Like, real question. Like,
I don't drive, so I don't know.
Fair enough. Well, for those on here that do, that would be asinine. And the reality is that's what we do every single time we do a build. If I change one line of code, I'm running every single unit test. I'm running every single. But why? So and again, so using the machine learning and using the understanding, let's do what actually changes. So let's look into the code, dig into it, understand what's actually changed, and then only run the tests that you need to. Or let's run the new tests that we didn't know about. Let's run the flaky tests, the ones that always fail. Let's run them first. Fail fast, get that time back. Because the last thing I want to do is every time I go to a build, go get more coffee. Right?
Okay. And actually, I'd like to dig into a little bit more on the artificial intelligence aspect.
Sure.
So often find with a lot of these things, the AI terminology is misused slightly. Like,
absolutely.
Does it learn, or is it purely reactive and kind of stays reacting in a certain way?
Great question. So actually, I do a talk on AI and ML. I did one 2 days ago, and we go specifically over what ML is, right? Whether it be supervised or unsupervised, and what it isn't, right? It's not just standard deviations. It's not thresholds. It's not these pieces where a lot of people say they have it. And so really when you get into neural networks where they're learning, that's actually where the artificial intelligence comes into play. And so yes, the answer is yes. And we can walk through them and with the time that we have. But ultimately, depending on the type of analysis and the type of data we're digging, we'll do different modeling. But yes, so not only can you give it neural feedback, so it is supervised in the sense of machine learning, but we've also had to learn to take things like a human would. So if I can talk about logs for like 2 minutes, they're really hard for machines to understand because I have to look at a lot of different things. I have to find only the signal. I have to get rid of all the noise because I don't want to grab every log you have. I only want to grab the things that are important. And then I have to actually understand what the exception is and where in the actual stack it is. And so I have to look at, similarities, but I also have to look at distances. And so now I have to cluster them. I have to go look at distances. I have to look at similarities. And I can say, hey, yes, it's a null point exception, but it's in a different part of the app. Or it's a different exception in the same part of the app. And having this understanding of where they're at, we need to be very clear with that. And that's where all the ML comes into play. So now I can start learning that, and you can actually give it feedback. So you get to give it neural feedback that says, hey, you know what, that's okay to have. We know what that is. I created that. Or we see that all the time. That's okay. Where the neural networks come in, where they're learning, and we use the data from our customers to build the neural networks, is that same understanding. If I showed you 2 logs that were identical, but it had a different account ID, you and I, as humans, would be like, oh, it's the same log. It's the same event. It's different user, different URI, different URL, different, GUID. Fine. Now I have to build a neural network that can actually understand that, right, at scale and can continue to learn as new paradigms come and as new things shift. And so that's really where our artificial intelligence comes in. It's understanding logs like a human would, so that I can look at 2 of the same logs with all the different pieces that would really make them not unique to you and I when we're troubleshooting, and remove those from the equation to only show you what matters. And to be honest, without that, when we did this in the beginning without using neural networks, we gave you so many false positives. Or not even false positives. I kept alerting on the same thing because it was a different user that caused the same error. That's not valuable to you. It was wasting time.
Yeah. Okay.
Does that answer your question?
To a point without, getting my hands on myself. That explains enough.
I can go into the actual modeling if you really want to. If you want to get super nerdy, but
well, let's spend a couple of minutes on it. Why not?
Sure. So if you think about it, the first thing that we have to deal with is what we call entropy, and really understanding, and like I said, understanding where the differences are. From there, we can start clustering. So we, traditionally we'll use k-means clustering to actually go and cluster them in the differences. Once they're clustered, now we have to actually do some analysis. So we use cosine similarity. We'll use different distancing technologies to understand literally where in the app those exceptions are happening and if they're actually the same type of exception. And so that's really the difference, is understanding, okay, what kind of exception it is and where in the application. Mm-hmm. Once we do that and we get it down to that smallest subset of that data set, then we'll apply the neural network only to the minimalized piece. So each time we're minimizing the amount of data that we're actually having to pass. If I ran that full neural network on the whole of what's coming into Splunk for you, the reason Splunk doesn't do it is there's not enough compute on the planet. And so really it's about bringing it down to a small enough aggregate that you can actually apply meaningful knowledge on the things that matter. And
I mean, does someone have to, I guess maybe this is a dumb question, otherwise what benefit do you get? But does someone have to sign up for the whole kind of the suite, or can you also integrate feature flag and CI processes from other places as well and benefit from something?
Great question. And the answer is it's entirely modular. So only use the parts that you need. And because we found it, unlike other vendors that make you have the whole kit and caboodle, we found that a lot of people have a CI tool. Mm-hmm. A lot of people have a feature flagging tool. So we partnered with other feature flagging modules. Really, it's about bringing that together. If it's something we can help you with, great. If you're using other tools, integrate it. No big deal. You don't have to go and change your processes. That's one difference between Harness and a lot of people, is that we've been built to integrate with all of these tools from the get-go. And that doesn't go away just because we have a CI offering of ourselves. We still allow you to kick off any of your CI tasks. If you want to use different feature flag modules, great. Right? If you want to bring in data from all your different monitoring systems and different cloud clouds, perfectly fine. However, we do have it as an offering if it's something we can help you with. And when you integrate them and you start taking action with that data, right, you want your pipeline tooling to be able to take that action. So it's a perfect fit when you really think about it, how that becomes a nice and a smooth integration, whether it's us taking the data from third-party tools or our own.
Yep. Okay. And say we're at KubeCon EU, which I've heard rumors of where it might be, or KubeCon North America next year. What do you think you'll be announcing then? What's next on the roadmap?
So we've got a ton coming on the roadmap. A lot of it we're keeping a little bit close to the vest, but really massive investments around more integration with Kubernetes, more cloud providers, really scaling it out to be able to provide all of the different, even open source tooling options throughout the whole process. Mm-hmm. So becoming, really it doesn't matter what tool you love, Harness can be that thing that's going to integrate it for you across the board.
I mean, it's the tool that can harness it.
Weird how that name just kind of works, right?
Next, Buddy Brewer and Mark Robinson of New Relic. So, New Relic. I have spoken to a company that you then took over last year, Pixie, but never you. So you've been around for some time, but maybe very quickly, if anyone doesn't know who New Relic is, we should quickly summarize what it is you do and have done for some time.
Yeah, happy to do that. We're an observability company. We help people understand what's happening in their software, and we want to help all the world's engineers make turn engineering into a daily driven or a data-driven practice for their observability. We got our start 13 years ago, and starting with helping people understand what was happening at the application layer. And since then, we've expanded to cover essentially every layer that there is in the stack. So we do full stack observability, not just from the application layer anymore, but from the front end, all the way through the application, through the infrastructure, and even down to the network now, so that engineers can use that data to help them make better decisions about how to build and operate their software.
And I mean, I'm sure the answer is a lot, but 13 years is a long time in this space. Observability has become a buzzword in the past 18 months or so. But I mean, conceptually, it's nothing new. So what do you think are the kind of fundamentals that have changed in that period of time?
There's been a major change that we've observed during that time. We've, as you pointed out, lived through it. The world 13 years ago was nothing like the way that it is today. And one of the biggest differences was that when we got our start, people built software largely in monoliths. Yeah. And you could understand that and you could predict a lot of the problems that were going to happen. And so really what you needed to do was with monitoring was to build instrumentation around those known failure modes so that you could be proactively notified in order to reduce the amount of time that it takes to fix those issues. Fast forward to today, and it's appropriate that we're having this conversation at KubeCon Cloud Native Con this year where, this is all about giving developers the tools so that they can move faster. But the architectural change that has enabled that has decentralized the way that software is developed into all of these microservices. And the surface area of things that can go wrong now is so large that it's impossible to predict anymore what's going to be the next failure. And that's where these unknown unknowns come into play that characterize the shift toward what everyone is calling observability today.
Yeah.
And we've shifted our platform in order to accommodate for that, not only in terms of the data that we collect, but also a big part of the story that Mark and I are here to talk about today with New Relic Instant Observability is about making it so that engineers can still manage all of that complexity quickly and easily, because it's gotten to the point now where people are developing software so fast that they can't instrument fast enough in a lot of cases to keep up with the pace that they're delivering software. And so at New Relic, we're working hard to make it really, really easy for people to maintain pace and wrap that telemetry around their software as they develop it.
It's interesting. So we can dig a little bit into this instant observability now, because I think I first encountered, in New Relic, I'm starting to scratch my brain, but I think it was when I used to do things like content management systems, specifically Drupal. I feel like I saw New Relic at DrupalCons when you did kind of know what the problems were going to be, usually database problems.
Yeah, all that. So we have a Python agent, MySQL, all of the pieces that go in making that go are part of our platform.
And then I kind of came into the kind of territory of things like Jamstack and static site generators. And I opened up the instant observability page. Sorry, it's late and I'm starting to slur my words. And I kind of was instantly thought of, I don't know, I started to think of things like, it made me instantly think of something like Netlify for some strange reason. Like, here's this quick thing I can deploy. And when it comes to like spinning up a website, I kind of get that. But when it comes to observability, so what are all these quick starts doing for me? What are they going to do?
Yeah, that's a great question. So if you look at it, the observability space is a lot of little things that you have to do. You have to put the agent in. You want to set up your alerts. You want to build dashboards. And that may be for one aspect of it. Now you're going to do that for your database server, your the language that you're using. What these are trying to do is simplify all of that for you. So it's a one-stop shop to get you from nothing to value as quickly as possible. And that's exactly where where we're seeing the biggest need is that as this complexity continues to evolve, we need to make sure that people can stay on top of it and that they can build kind of templates, menus. All this goes right into these these quick starts that set up everything. So it's like a pre-done configuration template that gets you to where you need to go to get value out of the system. And that goes from end to end, all the way from collecting the data through the agents to where you're seeing, you're getting your alerts, you're getting your insights, and you're seeing the results on dashboards.
And another thing that really struck me when I was listening to the keynotes this morning at KubeCon, and how some of the things that we're working on at New Relic align and how we share some things in common. One of the themes that kept coming up in the keynotes this morning was this notion of community. And this notion of the people that make the ecosystem go, as important as all of the technologies are, the community is critically important. And the same is true with observability. And it's one of the reasons why we work really hard with instant observability to open it up so that it's not only New Relic engineers who are putting these installable packs that you were talking about a minute ago into the ecosystem, but the workflow to get these quick starts into New Relic Instant Observability all takes place in an open process that flows through GitHub and around pull requests. And so it's the same process that our own engineers use to get one into the ecosystem is the same process that our partners use. So we've got 6 of those, half of whom are here at the conference with us today, who went through that same process to contribute to the ecosystem. And even an individual end user can go through that as well. So there's a technology component to this, but there's also a community and an open approach that we're taking to try and drive solutions to all these problems because it's so complicated to observe software today.
And how much do these build upon things you had already? Are they a replacement to them, or are they a supplement to them, or are some of them the same as those?
Yeah, very, very insightful question. Actually, a lot of this is built out of the components we have already. So it's not entirely new. Now, because of the way that it's pulling it together and creating more velocity, there are new things coming into it, but it's really just a better way of pulling these things together so they're more consumable, easier to understand. They don't require the same level of knowledge. Very few people want to spend their whole career becoming a New Relic expert. We all do in here, but we understand our customers have a lot of things they need to get done. And so we want that job to be super easy, and we want to get in there, help them, and get out of their way as quickly as we can.
Yeah, it's hard to solve a complex problem, but it's even harder to solve a complex problem in a way that's simple and elegant and saves people time. And so that's really what's new with the offering that we're launching today. We're taking capabilities that we had ways to get data into our system through all sorts of ways, including via open telemetry. We had ways to build visualizations and ways to build proactive alerting and all these sorts of things. But with instant observability, what we're doing is we're taking all of those technologies that we've built over all of those years and wrapping it into a single installable unit that within 5 minutes, someone can get all of that in place so that they can get back to writing better software.
Mm. And I mean, most modern applications are not one thing. So even with these instant observability quick starts is what you're calling them, can I kind of select a bunch of them and somehow get them to communicate with each other? Or is that the next step, I suppose?
Yeah, you can. We find that actually it's interesting when we were designing the concept behind this. One of the things that we looked at was how do people end up on New Relic's site in the first place? Yeah. More often than not, they're not searching for how do I install New Relic. They're searching for how do I monitor Kafka, or how do I understand what's happening in my node application. And so what we did was we built an on-ramp, and we also have a perpetual free tier, so it's really easy for people to get started. You don't have to enter into a commercial relationship. We wanted to see how far we can go, allowing users to stay focused on the problem without having to stop and then go focus on, what is this New Relic, thing? How do I, whatever. And so if you get through and you get something going with, let's say Kafka, because I use that example, and it turns out that, you've got a number of services that are written in Java to put things on that Kafka queue. Well, that's fine too. You can then go in and you can install the Java component, and you can do this. The idea is that you can do this quickly, and each time you do, you're enhancing your observability. You're adding another layer. But ultimately, all of this data goes into a single repository, which is really, really important, because it's only with all that data in one place that you actually have the opportunity to do what you were talking about earlier, which is connect that information together. And so what we do is we take all of the telemetry and we create this object model out of it inside of New Relic, where you can see not only the health of the objects themselves, the Kafka clusters, the containers and Kubernetes clusters and all of the different stuff at the infrastructure layer, the services that you've written in whatever languages, polyglot, architectures, all that stuff. You can see the health of those objects, but you can also see which objects are talking to which other objects so that you can follow that chain. If there's an issue that's happening 3 or 4 hops inside of a customer experience, you can navigate to that faster. That's all baked into the platform. And so we can do that as people layer in and they install more of these quick starts.
And I'd just like to understand something. So New Relic is not traditionally an open source company. Some of your providers and agents are open source, but the core is not. But you, on the instant observability page, New Relic IO is open source. So what is actually open source here? As far as I understand, it's just like a template for the quick starts, or is there something else at the core that's also open?
Yeah, we've been on a journey toward open source in a number of different ways. In particular, we've accelerated it over the last year. First, though, to take a step back, open source is relatively new to the observability and monitoring space. When you think about where open source software got its start, it began with the operating system kernel, right? Linux, then made its way through some of the infrastructure pieces like web servers and application servers, and then onto some languages. And when we got our start, there really wasn't much in the way, or really anything in the way, of open source monitoring or observability. And so we had to build all of these things ourselves in our language agents, which were, as you pointed out, proprietary. Today, there's a rich ecosystem of open source components, and we embrace all of those. And we also took our language agents and we open sourced those, so that is all under an open source license. I think you alluded to this earlier. We acquired a company called Pixie that does eBPF-based Kubernetes observability, and donated that to the Cloud Native Computing Foundation. And this is the latest step in our ongoing kind of position of really adopting everything that we do at New Relic. Is now, we start from the position of how open can we make it. So specifically to New Relic IO, instant observability, it's the workflow itself is all done in the open. So the repository where all of these things live are in a GitHub repository that's publicly facing. So anyone can go check that repository out, and they can suggest changes to it. That's all, something that's available. It's the way, like I mentioned before, that our employees work, but we're no longer doing that just inside of our organization. We're taking that and increasingly more and more of the ways that we build software, even at New Relic, and opening it up to everybody.
Yeah. Continuing down the observability path, definitely a topic of interest at KubeCon, is Anurag Gupta of Calyptia. Anurag from Calyptia. Is that the correct pronunciation of the company as well?
Yeah, you got both.
Yeah.
Calyptia. Yep.
What's the story behind the name there? I mean, I'm just thinking of Calypso, which I don't think it's got anything to do with. So no, it's actually, so the root of the hummingbird family is Calyptia. So Fluentd and FluentBit projects are birds. And so we used Calyptia and then made it a little easier, Calyptia. For some strange reason. So the bird logo in Fluentd is a hummingbird, is it?
It's a pigeon, actually. And then FluentBit is a hummingbird. And we said, let's just use the hummingbird. It's a fun little...
No, they are quite... I saw one once somewhere, and they're bizarre animals. They're very strange to see. But enough about that. So let's start a little bit with what Calyptia adds to this whole kind of observability story, because it's a very big space and increasingly big. And it's getting a little harder to kind of identify and break apart all the competitors in the space. So what do you bring to it?
Definitely. So, within observability, a lot of folks always concentrate on the back end, right? Where the value really is for users. You're doing the searches, you're doing the queries, you're getting the alerts. And that's awesome. Observability is awesome. It's helping all these users diagnose, troubleshoot, find all these issues. Now, from Calyptia's side, we have built these two really popular open source projects, Fluentd and FluentBit, that are part of the Cloud Native Computing Foundation. And where they sit in this observability journey is what we call the first mile, where you're collecting the data, you're parsing the data, you're getting it ready, and then sending it to all of these various backends. So from Calyptia's side, we think of this first mile as being everly more important in today's observability journey, where you might not necessarily want to send everything to a single vendor. You might want to route to multiple backends. And especially as there's different data types coming in with metrics and traces and logs, how do you go and capture or correlate these things when you have all the context, which is where you're collecting that data? So for us as Calyptia, we've built a number of solutions around the first mile, increasing the adoption of our open source, as well as tooling and services on top of the open source projects, which is Calyptia Cloud.
Mm-hmm. Let's go down the stack a bit, because I wouldn't mind breaking these apart. FluentD is probably the best known of the various projects we just spoke about there. And that's a logging, well, the project page says logging layer. What is that? Is that a logging aggregator, a logging collector, a bit of everything? Like, what is it exactly?
Yeah. It's a bit of a dated sentence, because so FluentD is about 10 years old at this point, right? It was back when there was all the Apache Flume. Facebook had this open source project called Scribe, and Heka was a Mozilla project, if folks remember that. And you had Logstash as well from Elastic. And the idea with FluentD was to say there are so many different sources and there are so many different destinations. And collecting data is very hard. How do you do it in a way where you might have sources that come from the network, that come from log files, and you might have destinations like Amazon S3. You might have non-cloud-based destinations like an output file. And FluentD was built around this plugin ecosystem, so you can plug and play your different sources, your different outputs. You can plug in different filters to do different types of mismatches on top of it. And the other big benefit of FluentD is it was built to be very, very flexible in its architecture pattern. So you can deploy it on a virtual machine, bare metal machine, in a container at the edge, or you can put something kind of in the middle, and we call that an aggregator. It's like a heavier instance of FluentD, built for like hundreds of thousands of messages per second. It's running multiple processes, and it's doing maybe more of that like filtering at the kind of core network layer before you send it off to a particular destination. So from that point of view, yeah, FluentD is meant to be, hey, you have full control over all of this data that's flowing in your ecosystem, and being able to say, okay, I want this part to route to Kafka, this part to route to Amazon, this part to route to a log analytics service. And that worked out quite well for many very, very large banks and insurance and tech folks and whatnot. Even, adopted, I used to work at Microsoft. Okay. And we were using FluentD as part of the Microsoft Log Analytics agent or the OMS agent. And so if you wanted to send data to the Azure backend, the Azure Log Analytics backend, as well as metrics, you would install our agent, which is just a cover around FluentD, and go on collecting and routing all that. So, yeah, a lot of flexibility there.
And then, so what is FluentBit? That's one I hadn't actually heard of before.
So FluentBit is actually part of the same ecosystem, the same FluentD ecosystem. It was created in 2015, a little bit after FluentD. And what we noticed in FluentD was there was this ever-present, we want to have more performance and we want some stuff to be lighter weight. At the time, it was actually all about embedded Linux. IoT was the hot stuff of 2015. It was the observability of 2015, if I may. And basically, in order to
it kind of still is. It just seems to be renamed Edge recently.
Yeah, exactly. Every now and then IoT comes back into play. And so for the Edge IoT, we built FluentBit, which is a whole written in C, built for embedded Linux, super lightweight. It didn't have maybe some of the shortfalls that FluentD had with you have this enormous plugin ecosystem, but you don't know which ones are good, which ones are bad. And if you want to add a bunch of plugins, it takes a little bit. But with FluentBit, we just have all of them out of the box. So you get like kind of 80 well-functioning Azure, Google, Amazon compatible plugins right out the box. And it just so happened in 2015, 2016, you had kind of this advent of containers. You had the advent of Kubernetes being open source, and stuff that works well on embedded Linux for lightweight workloads works really well in containers as well. So FluentBit was kind of that natural extension to FluentD, where now you could say, hey, at the edge, the VMs, we're going to have this lightweight, high-performing FluentBit agent, and then in the middle we'll have FluentD, which has all of the power of parsing, filtering, and we call this like the forward aggregator pattern.
Okay. And so then, I guess then Calyptia uses both of them depending on the use case.
Right. So we have, our company was created, my co-founder Eduardo created the FluentBit project, and FluentBit more recently has just been growing at enormous velocity. So basically in this year alone, we've had about 500 million deploys on Docker, about 2 million a day. And you just have all cloud providers kind of looking at it. And when you deploy any of their Kubernetes services, you typically find FluentBit already there. So the Google Ops agent has FluentBit as part of it. With Amazon, there's this whole Amazon ecosystem. They actually have like a fork version AWS for FluentBit. And so it's great. We think that the ability of high performance, low resource usage it's not a trend that ever goes away. And this gives us a really nice base to build on top of. That being said, FluentD is still very, very popular, has tons of plugins, and we want to help users as they
you definitely still come across it. It's not. So I'm still trying to understand a little bit where Calyptia fits into this, and I get the impression it's a relatively new product / company.
Yeah.
So, I mean, I think I need a little bit of unpacking about what you meant when you said first mile earlier, and you mentioned this a lot on your blog as well, and I still don't entirely understand what you mean by that.
Sure.
So maybe a little bit of unpacking about what that means, and then what you're adding on top to FluentBit and FluentD that you think brings the kind of the magic to what Calyptia is. Calyptia. No, that was correct. Calyptia is.
Yeah, absolutely. So to back up and go a little high level right on, what is first mile observability? What is this thing that we're naming? We think of maybe the first step when you want to go and extract value from your logs, metrics, whatever it may be, is you need to collect those pieces of data. So typically, if you're using a vendor, they will recommend, hey, go install this agent. Go collect all that data and use this either API key or endpoint, and you'll send us the data, in which case you can start doing all the searching and everything. Now, within that process, the vendor will typically recommend their own provided agent, which we feel comes with a couple of problems. Number one is that agent is a bit of a lock-in. You're only going to be able to send to that one backend. Number two, it's many times, not all vendors will have a all or nothing type philosophy. It's like everything is on or it's off. And you might not be able to do some of the parsing that you need ahead of time or the changes you need ahead of time to get that data in the most useful state for that backend. And then the third is a bit related to the first two, is that when you're collecting more and more and more data, you are essentially paying more and more costs, right? Data and costs for most backends are linearly related, but value is not, right? I could collect 10 terabytes of debug logs, but it doesn't necessarily mean that I'm going to get 10 times more value out of those logs. So from our side, we see that whole collection and that parsing and routing and filtering as what we call the first mile of observability. It's getting all that machine data into a state that makes it the best usable type data for your observability backend. And it just so happens that these projects, FluentD and FluentBit, why they're so heavily adopted by many folks is because you can do a lot of that type of functionality as you collect that data. So an example is when users try to collect logs from Kubernetes. Probably the most common use case for FluentD and FluentBit is you'll deploy these things as the daemon set, which means that for every node of Kubernetes, you have one instance running, and it will collect logs from all the applications within Kubernetes, and it will route that data. But it doesn't just route that data raw, because you lose a lot of the context that's needed to efficiently diagnose and troubleshoot. So what does it do? It goes and talks to the Kubernetes API server and says, hey, I'm getting this log from this container called Nginx. Could you show me what namespace, what pod, what region, what geo, all of that information, and add it on. So that way, when I'm debugging a issue, I don't have to just say, I ran into an issue with Nginx. I can say, I ran into an issue with Nginx on this pod and this namespace all the way over here. And that enrichment is really, really valuable for those users. And likewise, I could also say things like, hey, I'm collecting all of these logs, these debug logs, but I don't actually find any value with it. I want to keep it for compliance reasons. So instead of sending it, say, to this backend that might be a little more expensive than I need it, let me send it to something really cheap like block storage.
And I mean, I suppose you were predominantly at KubeCon, as far as I can tell, to announce the product. So that's the main thing you've been up to recently.
Yeah. So maybe two reasons we were at KubeCon. As part of KubeCon, there's these co-located events around all these other projects. You have PromCon. One of the big ones was also FluentCon. Mm-hmm. So we were there as kind of a sponsor and help organizing it from a community perspective. We had a lot of folks chat, like folks from Fidelity, folks from DigitalOcean, Chronosphere, and other notable Logs.io and other notable observability folks. And then the second part, from a commercial stage, Calyptia has announced a cloud service. We call it Calyptia Cloud. And we want to make it so that it's very easy to get started with these Fluentd and FluentBit projects. Mm-hmm. Make it so you're more successful as you start to undergo this first mile journey. And so what we do as a cloud service is we just plug into what is already available in open source. So from open source, you can attach those things up to Calyptia Cloud, and we'll do kind of three main things. One, give you some turnkey visualizations. Mm-hmm. So as you're routing all this data in first mile, it's very easy to get very complex. Mm-hmm. And so you can start to do things where you might be like, I don't know how my data is flowing. I don't know what it looks like. And so we make it very simple to say, here's how your pipeline looks. The second thing that we do is we collect metrics or metadata about the Fluentd and FluentBit instances running. Okay. And that can start to tell you and paint pictures about, hey, you're sending a ton of data to this backend. Is that intentional? Or, hey, I'm collecting data from this source. Is that intentional? So it gives you a little bit more insights about like your source and destinations before it gets sent out to those end destinations where you're typically paying the money for it. So it gives you a little bit of insight there. And then the third piece is really optimization metrics. So we have a lot of filters, and we can tell you, hey, your optimization rate for, say, this log from an event perspective might be 0, but a byte perspective is 50%. And what that means is, like, say you have this 100 kilobyte log message, and a lot of times, especially in like Java apps or even Windows event log, typically repeating that message a ton of times. And there's a lot of duplication with just the verbiage itself. So what if we just throw away the duplications or the pieces that are null? You can save a ton of space that way in the message itself. So giving folks the ability to understand those different types of optimization styles and whatnot.
Final interview in Observability Corner on this week's episode. I have Martin Mao of Chronosphere. I should add a little disclaimer here. I actually currently work for Chronosphere in my day job, but I try not to let that get in the way too much, I hope. So Martin from Chronosphere, you've actually been on the podcast before, just under 2 years ago, actually.
I have. It was actually when Chronosphere just came out of stealth. It was the very first conference we attended was Velocity Berlin, and that's where we met about 2 years ago. Yeah.
And it's been pretty eventful past 2 years. I feel like we could possibly have an entire conversation on that, but let's focus a little bit on the announcements and things that got you to KubeCon. But maybe we should fill in a little bit of gaps before all that and explain what is Chronosphere. It's one of the many players, but one of the, I suppose, rapidly emerging new players in the whole observability space, which is really quite popular at the moment. So what specifically in that space does Chronosphere fill?
Yeah, so we are, as you rightly said, an observability platform. All that means is we absorb various types of data like metrics and distributed traces. We store them and we make them available in our SaaS platform and tooling to allow end users, which are generally our developers, to debug issues, get alerted when things happen, know what's going on, and fix or find the root cause of underlying issues. So that's the general sort of product that we provide. As you rightly said, it is a very hot area right now, observability. And the reason for that is actually, if you think about the broader industry and our technology stacks, that's undergone a huge shift recently, right? So up until a few years ago, people were definitely transitioning to the cloud, but it was really lifting your on-premise workload, dropping it off on VMs in the cloud. And all of our APM tooling were working as they were. Your IT and monitoring tooling was all valid. But perhaps there was some new solutions like Datadog that were tailored for these cloud environments. What we really see in the last 2 to 3 years is a huge shift to Kubernetes, to container-based environments, to microservices architectures. And it's really that shift that's causing everybody to realize, oh, wait, APM is not the right solution anymore. I really need something for this new architecture. And that's what's, I guess, perhaps unique about Chronosphere. We do provide an observability platform for this workload. And what's unique about us is all of the underlying technology that we had built was purposely designed for this architecture, not the old architecture. So you could attempt to repurpose some things from the old architecture to the new one, but it's just you can imagine much more performant, more reliable, more cost efficient when you're building for this architecture from day one. And that's sort of what we did at Uber many years ago now. Here we are with our product at Chronosphere.
This is possibly a strange question to ask when we're on the back of KubeCon, but
yeah.
In I don't know, 3, 4, 5 years time, when everyone's given up on Kubernetes, has gone to something else. I mean, how will the plethora of products and companies at the moment kind of focus specifically on the Kubernetes use case not get left behind?
No, it's a great question. I mean, that could definitely happen. And even at Uber, we were really building this for Mesos back then, not for Kubernetes, right? Yep. So perhaps the technology, to your point, could be phased out, although we are seeing that all 3 major cloud providers are getting behind it now. VMware is betting big on this. So it does seem like a technology, at least, that is adopted across all of the big cloud providers, perhaps these hybrid plays as well. So perhaps it would be here for a little bit longer, but that's completely true. But it's not necessarily the Kubernetes technology itself. It's more about containerization. And I think that process will just continue, whether it's Kubernetes or not. In fact, as we look at things like serverless these days, it's the same concept of like smaller pieces of work as opposed to a larger running application or monolith or anything like that. And if you even look at like other parts of the stack, like if you look at the networking stack, that's gone from physical networks to software-defined networks to sort of almost virtual function networks as well. So like everything is still going on this trend. I think that trend will continue regardless of perhaps the current flavor, which is Kubernetes right now. So I think if you look at a lot of companies and if you look at sort of what Chronosphere targets, we don't say we're a Kubernetes observability platform. We're sort of a cloud native one, right? So it's all about this type of architecture. There's nothing specific to Kubernetes. So, I think the companies that are out there that are maybe building Kubernetes specific things may be at risk, but generally if you're building for this general type of architecture, I would imagine for at least a decade, you're probably fairly safe. But yeah.
I urge people to hear kind of the story behind the origins of Chronosphere and the open source project that it's based on, which is M3.
Yeah.
To go back to the episode 2 years ago to hear some of those origin stories. So let's specifically try and fill in some of the gaps up until KubeCon. What have you been mostly focusing on?
Yeah, when we chatted 2 years ago, we I would say barely had a product out, but we started with M3, which was our underlying storage engine for metric data. And that had already been proven at Uber for these type of environments, but it wasn't a product. People were not trying to buy a database from us. They're trying to buy a actual observability solution from it. So really, since that point in time when we chatted 2 years ago, a lot of it has been building the platform, building the product on top. So we do store still today all of our metric data in M3, and that's sort of been battle tested and very solid. But really, people are sort of buying the product sort of on top, and that's really where we're differentiating. Actually, is the features that we put on top. One of the big areas of investment, and you'll see this perhaps on the website today, is our talk about data control. So one of the concepts that we have realized in the last couple of years, and we realized this at Uber as well, was that just especially as you do this transition to microservices on containers, that the amount of observability data increases exponentially, already in that one-off switch. But over time, it continues to increase. And it makes sense because if you think about it, most of these companies are hiring more developers. They're coming in and writing new services. They're not just maintaining the existing stuff. All companies are trying to innovate and build new features, new services. All of that produces, you can imagine, more monitoring data, and you don't really necessarily deprecate the old stuff as you're doing it, right? So the pattern we see is that the volume of data continues to increase exponentially. And in fact, it's increasing at a pace that's far outstripping the growth of your underlying infrastructure. And that creates a really bad dynamic because generally all the tools that you would buy in the observability space, or if you were to run it yourself, all of it, you can imagine if you 2x the amount of data, generally you're paying twice the amount of cost. Again, if you're buying your own hardware or paying for a tool out there, it's that sort of trend. So generally what ends up happening is companies end up paying proportionately more of their overall infrastructure spend on monitoring and observability, yet they're not getting the value out of it. Like if you think about what a business needs from these systems, you need to know when something's wrong and how quickly you can know. You need to be able to fix the issue. Those properties are not necessarily changing. In fact, they're generally either the same or they could be getting worse. If you have 10x the amount of data, it could actually be harder to tell when something's wrong and harder to tell or like to figure out the root cause and to fix it. So we're really seeing in the industry sort of a divergence between the value I get out of this thing and which doesn't really change very much over time, and the amount of data that's being produced, and hence how much I have to pay for this thing explodes. So a lot of our focus here at Chronosphere is, yes, we have the better efficient technology underneath the covers, and we originally thought that was the way to solve the problems. Like more data, no worries, let's store it more efficiently. Yeah. That's the way to go solve the problem. There's unfortunately, as you know, we perhaps see with like CPU cores and whatnot, there's like a point in time where that doesn't work anymore, and you just can't make the storage more efficient. And we sort of reached that point. So really a lot of the focus of Chronosphere and the platform we provide is sort of moving up to the control of the data itself, and really having companies understand, okay, you're producing 10 times the amount of data, but do you really need to leverage 10 times the amount of data? Are there things that we can do like customize the retention of that data, customize the resolution or the level of detail of the data? Or could we pre-aggregate a lot of that data for you, thus that we can answer the questions you're still looking for without storing every piece of data? And that has been a huge differentiator, because as companies continue to grow, more and more companies run into this problem, and it's a problem that is fairly painful, I'd say. And that's really where Chronosphere, I'd say, it differentiates a lot. But that's really what we've been focusing on the core platform the last 2 years.
Some of the other observability platforms I've spoken to as part of this KubeCon have tackled this aspect in a slightly different way, and I'd be interested to. I'm undecided myself which one is the better idea. I suppose we'll see. But has Chronosphere ever been tempted to go down this path of kind of taking away the control and letting things like machine learning take that control? Because machines can filter large data sets quicker than humans. Of course, we know the negatives that can come out of it. Yeah. But is that something you've considered, or do you prefer to give the humans the control?
No, it is something we've considered. And I think a lot of the approaches right now on machine learning is not necessarily on optimizing the data yet. They need to have all of the data. They're trying to even make the machines almost replicate what the humans can do in terms of detection and root cause analysis. You got to do that first, and then you can perhaps have a chance of optimizing the data for that, right? So I think a lot of the solutions out there are optimizing for even can you replace the human in the sort of solving of the problem phase, as opposed to the optimizing of the data. So that's already fairly different, and generally you need even more data to feed the machine more than anything else. So it doesn't really solve that problem. However, what we found is that, and we sort of tried this approach at Uber as well, where we attempted to apply machine learning to it, and the problem with that is the signal to noise ratio was extremely low. And the reason for a lot of this stuff is for a machine, it's relatively easy to detect correlation. So like you can imagine if like a CPU spikes and the error rate spikes, correlation of that is really easy to detect, and machines are great at that. But what humans need is not correlation, because you can imagine when a big incident happens, everything's on fire. Everybody knows that everything's on fire, right? What you really want to know is what caused what, A caused B. And that is something that just purely from the data with no context on the services and how they interact with each other, because these are complex services built by humans, the machines really struggle for causation. So when we tried this, we found that machines could never get the signal noise ratio past maybe 60% or so. And the problem with that is you can imagine as a human, because the machines cannot necessarily remediate. They can tell you when something's wrong. Here's a signal. As a human getting woken up in the middle of the night with a 60% probability chance that it is a real issue, you can imagine annoyed the hell out of a lot of people, especially because the machine determined it, not a human. You can imagine when you set up the alert yourself, you have nobody to blame but yourself. But when there's a machine, you have somebody to blame. So a lot of humans in the world know how to drive, and yet you can see we're still trying to perfect self-driving through AI and machine learning, right? Whereas like how many humans in the world can design and debug a large, complex, distributed system? Very few. And we're going to try to apply machines to that problem, I think, is a much longer tail. It's going to take much longer to solve. However, that doesn't mean that the human has to do it alone. So what we found was far more effective was to really give humans data science techniques like week-on-week trend analysis, standard deviations, things that make sense, but like can not really be applied automatically. And a human who knows the system, knows the seasonality of the data, for example, or knows what to expect, can use these, and it's not really machine learning, it's really just data science, use these techniques to solve the problem.
Okay, so let's fast forward to KubeCon. I think you had a relatively busy one.
Yeah.
What have you been working on? What's new? What's news?
So there's a couple of big announcements. And the one I'm a lot more excited about is adding the capabilities of, extending our root cause analysis capabilities by allowing the platform to ingest distributed tracing data. And that's a pretty big move for Chronosphere, because when we started with M3 and we're storing metric data. Metric data is generally great at doing the notifications and notifying everybody of when something goes wrong. It's also great at sort of triaging the issue. So when something goes wrong, how bad is it? Do I really need to pay attention now? Is it all my customers or just a single one? And it's great at that, because those analysis, you don't need the details. You just need the aggregate view of things. And that's what metrics are, is an aggregate view. Root cause analysis metrics are slightly less effective at, because you don't get the individual details. You're like, I see that there's one error, but I don't know who it is. I don't know which customer it is. I don't know much details about that. So this is where distributed tracing data comes in handy, because it is the whole, the detail of the entire request through your complex system end to end. And that's the piece of data that you need. In isolation, you can imagine both systems don't really solve the problem end to end. They're really applied at different phases of the problem. You need to know that something's wrong first, otherwise you're not really doing root cause analysis. You need to triage it to know whether you need to do it right now or later, and then you need to do the root cause analysis. So the addition of distributed trace data sort of completes that workflow for us, so we can sort of handle the whole workflow end to end. Really excited about that. And we do that in a fairly different way that I can talk to you about separately. And then the second announcement was just the funding. The business has been doing extremely well this year, and we took a Series C recently that I guess caused a little bit of noise as well. So also excited about that, because I think it goes to show that that there is enough pain in this area right now, and everyone wants to solve this problem, and we just happen to be in a good spot to solve it. So it's because of that I'm fairly excited about that piece of things. But yeah.
And does with the tracing, do the tracing and metrics kind of tie together, or are they like that's over here and that's over here, or the two are connected?
Yeah, no, they are definitely tied together, and this is why we didn't release a tracing product. The one and only platform that we offer, the Chronosphere Observability Platform, now leverages tracing data. So this is where, and it happens in multiple ways, but this is where we actually extract metric data, aggregate data on top of the traces that we collect ourselves to allow our customers to alert off of that and to triage off of that. Right. And then because it's extracted, we know exactly the source of all of that data and which traces they belong to. So you can imagine we're really optimizing for that flow end to end. It's not a separate sort of piece together experience, perhaps as a lot of the other platforms out there are. And it also doesn't require people to sort of, a lot of these platforms out there require a lot of pre-configuration and pre-instrumentation. You have to set everything up in a particular way such that you can make that jump from A to B to C. Whereas for us, you just send us the trace data and everything else is already connected for you behind the scenes.
Okay. And let's fast forward. I gather KubeCon EU is going to be in Valencia. You have 6 months' time. KubeCon Valencia, or a year's time, KubeCon wherever it may be in America.
Yeah.
What do you think you might be announcing there, in vague terms, if you like?
Yeah, that's a good question. I would say that 6 months or a year from now, the pattern that we're on now, as you see, is not new products necessarily, but sort of improving the functionality and the capability of the one observability platform. So I think that is the pattern that you're going to see moving forward. We're going to add additional functionality. We're going to add additional functionality to continue to optimize each of those three phases, the notification, the triage phase, and the root cause analysis phase, through different features here and there. We're also going to continue to sort of push on this control piece and the control of the data right now. A lot of the power is there. But to your point, and you're asking about machine learning and whatnot earlier, sort of some of the focus there is trying to make that as easy as possible for the end users to optimize their data. Again, not for machine learning, just very, very basic data science techniques can go a long way there. So I think, if you look at the overall trend, that's probably where it's going to go. I don't know if I have a particular feature and whatnot that we want to preview here in that time frame, but there's definitely a lot of things that we will continue to build. We're definitely, even though there's been a lot of business traction thus far, we know we are nowhere near done right now. We have something that's very differentiated, which is fantastic, but there is so much more to go. And, that will be like a multi-year roadmap.
Next, the return of Chang Li from Hashicorp to the show, talking this time about Waypoint, a kind of Kubernetes deployment abstraction tool. So, Chang, we speak again. I think we spoke after the last KubeCon EU, I think.
Yes.
About Nomad, but we're actually going to talk about something else. But we're going to talk about Waypoint from HashiCorp, which I get the impression is, I've not heard of it before, so I assume is reasonably new, or maybe I just haven't been paying attention. What's the history of the project or the product?
Sure. So Waypoint is one of the newly launched open source project. We actually announced last year at HashiConf, so this is a 1 year anniversary. It is kind of one of the newer projects. So very excited to talk about, Waypoint today. Okay.
And so what is it?
Good question. So Waypoint, it's, if I use a simple sentence to summarize, it's essentially an application deployment tool. So the goal or these two aims to solve the deployment workflow challenges for developers and operators. So it's mainly on how we can simplify and make it more efficient for their build, deploy, and release steps, from a development environment all the way to production ready platform, and make that kind of deployment workflow efficiently and consistent across multiple release platforms like Kubernetes, ECS, Nomad, and etc. So that's essentially, I think the deployment workflow, or you say developer workflow, is something Waypoint is trying to solve.
So is it specifically into the workflow, or does it also fit into this kind of world of, no one's really quite settled on a term for it yet, but is kind of like ephemeral environments, developer environments, that kind of world as well? Or is it specifically about more just getting to a deployment?
So I think it mainly to solve if you kind of break it down, mainly to solve two sets of challenges, right? When we talk about developer workflow, normally there are two types of audiences, right? You have developers, right, who's writing their codes, trying to move from their local laptop to production as fast as possible, right? So, and also you have operators, the other side. Let's talk about developer first. I think their main challenge is like, we have this different orchestration platform like Kubernetes, like ECS right now. I have like Nomad, serverless platform. They all help to automate this application deployment, right? But they're still very infrastructure oriented. That means their abstraction is heavily kind of infrastructure oriented or operator friendly. So as a developer, not only I have to learn, right, all this inner workings for the underlying technology, but I also have to interact with these technologies. Let's make a quick example, like to deploy a simple 2-tier web application in Kubernetes, right? One of the most popular deployment platform. You have to interact with dozens of Kubernetes resource and objects like pods, deployment, replica, secret, config map, right? Ingress, whatever. So you see, and services. So there's a lot of infrastructure abstractions developers have to interact, right? How to minimize their cognitive load to really focus on application-centric abstraction versus infrastructure abstraction, which actually differ when you cross from Kubernetes to Nomad. It's a different set of abstraction, right? Moving to ECS. That's one type of challenges. Okay. When we look at operators, I think operators is more about what we just talked about, right? So you were in KubeCon this week, and you see like every time we see the CNCF chart showing the open source project that CNCF are now hosted, it's an ocean of like different vendor solutions. And I think the past few years is like if you look at any specific areas around the Kubernetes ecosystem, they already have a lot of tools trying to really mature and operationalize Kubernetes in a more, make Kubernetes more powerful, more comprehensive, right? More ease of use, but mostly from an operator point of view, right? Yep. So operators, they're the kind of the folks trying to build this automated workflow across each stage of the application lifecycle to try to kind of using, different tools at each stage and trying to achieve some levels of consistency to help developers to move their code. But because they have like so many different tools to choose, and also they could be kind of depends on their environment or their applications, it's oftentimes they codify their workflows very kind of inflexible. So it's like inflexible workflows. It could be kind of limited shared knowledge from project to project, like from one project to another project, you could have different workflows, or from one team to another team, you have completely different workflows. Even sometimes from environment, like from local development is one workflow, production is another workflow. So there's very inconsistent developer experience overall, right? When you look at all the organizations. So I feel like if you look at the industry trends, there's still a lot of operator oriented or like infrastructure level improvement under Kubernetes or CNCF. But I think internally, like companies, they're now focusing, let's moving up our focus from operators to developer. Let's see how we can actually not glue things together in a kind of ad hoc way, but really look at how we can simplify, streamline this developer workflow for their developer, because they're the end user and the consumer, right? How we reduce that cognitive load, how we simplify things. So this is something I think Waypoint's is trying to solve, right? First, let's simplify the abstraction, right? Let's simplify the way we define application. And the second is like, let's have a more, like a simple, can be as simple or as complex, opinionated workflow to build, deploy, and release, right? You can have Waypoint have a very simple deployment workflow, or it's also a pluggable framework. So you can actually integrate with your existing CI/CD pipeline, your existing APM solutions, right? To make it more advanced and suit your own needs. Yeah. But I think the ultimate goal is like, we want to build a kind of a PaaS-like experience. Funny thing, I think Kelsey Hightower once posted a Twitter saying, every operators in a large organization want to create a PaaS experience for their developers, right? I think our goal is like, we want to create a PaaS-like experience for Kubernetes, but the difference from us compared to other Kubernetes native solutions, we want to be able to scale that experience consistently across other platforms like Nomad, like ECS. This is kind of the basic principle our HashiCorp product has is like it has to be technology agnostic. Yeah. It works not only for one platform, but also multiple platforms. Yeah. So it's a very long answer, but I feel like it's important to unpack the challenges.
I wanted to dig into a bit. Actually, the main thing you said in that answer that attracted me was an application perspective instead of an infrastructure perspective. So without having really dug into Waypoint too much right now, I mean, so how does this look? I mean, can I literally say, I want to have... Yeah, I can't think how I would even say this, but what's the level of abstraction I can kind of go to just think from an application perspective instead of an infrastructure perspective? Like, what do assuming you use kind of the standard HashiCorp ways of config files and things, what do I do? What do I write?
Yeah, so that's a great question. Our goal is now to create another different definition of abstraction. That means the operators or developers not only have to learn each individual, but also have to learn new language. Yeah. That's not our goal. I think what we do is we allow operators to only expose whatever they feel needed to developers. For example, it could be as simple and could be as advanced, right? For example, for 0.6, we now support auto scaling deployment. So if you look at how you have to do it in raw Kubernetes environment, it's like hundreds of the YAML, like lines of YAML file. But if you look at how Waypoint do it, it's very simple, like 5 lines. You set what is your metric, right? CPU bounded, okay? And then you tell minimum replica, maximum replica, CPU criteria 75%. Voila. That's all you need for, I think that's what we call a YAML free. It's still YAML. It's not we're recreating, but as a developer, I really don't need to understand. I'm just exposing whatever information I needed to run this auto scaling. Everything is behind the scenes. It's like Waypoint will taking care. So okay. I just need to know. Yeah, we're not like introducing a new kind of abstraction. We're just exposing the right amount of information that is more application centric.
Yeah. So it also looks like you on the whatever you want to deploy to, you need to install a Waypoint server as well, as far as I can see.
Yeah. So Waypoint has this concept. It's like you have a Waypoint server, and Waypoint also have this called runners to execute jobs remotely, right? Say if you want to perform a build, you say in a Kubernetes pod, we have this called on-demand runners will kind of perform these jobs in a single-use ephemeral pod. For example, you build Docker images, then you just the Waypoint server will kind of create this one-time on-demand runners to perform that, and the pod will get destroyed after you complete the job.
Okay. And I mean, so is Waypoint designed as effectively just as a start point? If I want to do something more complex and more nuanced, then I don't use Waypoint, basically. Or, you know, where's the cutoff where you think, you know, this is a job for a different tool?
That's a great. We initially, I think that when the team initially designed Waypoint, we wanted this to be extensible. So it's now you will eventually migrate it off Waypoint, but Waypoint is complementary. It can be integrated, say, with your GitOps workflow, right? Or with your CI/CD pipeline. So you can have a simple like Waypoint by itself without, but you can also migrate with your existing CI/CD pipeline or GitOps. For example, we already have GitOps support. So that means any push to GitOps, like Git repository, can trigger Waypoint to update applications, or change applications automatically. So we already support a complete build, deploy, and release workflow with GitOps workflow. So I would say this is almost like Terraform or like any HashiCorp tools. Is we know the value of ecosystem, right? And also we don't want to limit the choice the customer want to have for their tool chains. So it's all about building an extensible or pluggable framework so you can control how simple or how advanced or complicated you want.
I had one other question, but something you keep saying, I just want to clarify. You keep saying YAML free. So I think maybe I got confused earlier. The 5 lines of configuration you mentioned, that isn't YAML, or it's just something else?
So it's actually still the thing how they define in Kubernetes, right? We're not creating something new, but that's something. It's like a human readable. Yeah, no,
okay.
it's not like I don't. Well, if I'm a developer, I don't know YAML, but I can understand what's the CPU limit. I can understand what's the maximum replica. You know, you got my point. It's like I don't need to understand all this jargon, like YAML specific these manifests, right? But I can directly define and get it deployed.
Okay, all right, I get you.
So
okay.
So it's like you don't need to learn YAML, honestly.
Yeah, well, it's not necessarily learning YAML; it's learning the Kubernetes hundreds and hundreds of lines of configuration.
Exactly. Yeah. Okay. Actually, you made a great point. Like whether it's YAML or not YAML, it's JSON or not, that's not the pain point, right? The pain point is about all the Kubernetes objects, resource configurations that developers had to interact with.
But the other thing I wanted to clarify, so how deep down the Kubernetes kind of pathway can you go with Waypoint? I'm not entirely sure if this is really a use case of Waypoint, but it just came into my head when we were talking about a YAML. You know, you have this concept in Kubernetes of like custom resource definitions. So like the Prometheus operator and things like that, you know, that people make. I'm starting to wonder if something like Waypoint even wants to get to that level, but can it go to that kind of level, or is that a bit too big and broad right now?
That's a brilliant question. Honestly, I think internally the team, we have this debate on what's a priority of building these tight integration, you know, with like how much we want to support Kubernetes, how like you said, how deep we want to go into the weeds. I think it's I wouldn't say it's not on the roadmap, but everything's like we want to do this from a more kind of developer centric or customer centric. The way we prioritize things is like what would benefit the customer the most practical, right? Because some features are, I would say, kind of a lip service or checklist. It's like, oh, I support CRD. You know, it's like that's something everyone may want it, but they not actually use it or in the right way or, you know, in the most efficient way. So we have our Terraform provider. If you ask me, then my take would be we probably prioritize Terraform provider more than CRD. I think it's purely based on eventually what we see the actual customer needs or customer ask come from.
Okay. So say we're speaking at KubeCon. I've heard apparently it's Valencia. Hopefully actually be able to make one again. That'd be nice. Or wherever the US happens to be. So in 6 months or a year, what do you think you're going to be announcing? What are you working on?
I think by the time, we have a very aggressive kind of like roadmap towards Kubernetes. So I would like in 6 months we'll probably in a much better, hopefully we can deliver kind of a first class PaaS experience on Kubernetes by that time. So I don't know exactly, you know, like what are I know we have a lot of features on how we enhancing. This is actually pretty cool. It's like today when you moving from different stage, like from like staging, development staging and production, people tend to have a set of configuration files, like independent. It's actually not independent. It's like some version and drifted a lot across different environments, right? But you have duplicate. That's like how GitOps doing all this version control. But Waypoint have our own opinion way or workflow. Is like we want you to reduce these kind of configuration file sprawl or YAML file sprawl. You can have one single configuration file, but there are variables you can change that can, you know, move resource efficiently. That means you only have one set of configuration file and different variables you can play and for different environments. So it's just how we can further simplify your deployment workflow. So I think we have a lot of very ambitious goals. Definitely, I would say hopefully by next KubeCon, EU or US will have a much stronger and more comprehensive Kubernetes story to share. hopefully by that time I have a better solution answer for you for the how we support CRD or now, like whether or how we support CRD. Also let's see how CRD itself evolve, right? How customer adopting that too.
I have seen. And finally, Laurent from Cast AI, a tool that helps you evaluate the cost effectiveness of your Kubernetes deployments and what you could be doing about them. Okay, so Cast AI, welcome. I want to say Laurent, but I'm not sure if that's correct.
Yeah, that's right. That's right, okay. Laurent. Yes.
So Cast AI, it looks like you fit a little bit into a category that's popped up I've seen in a few places recently around kind of streamlining cloud costs. We've got to a point where people are using cloud so much, we now need tools and services to make it cheaper again. Or maybe I've misunderstood, but give us a little bit of a quick introduction to what it is, what Cast AI is.
Yep. Thank you. And that's exactly what you said. We are a cloud cost optimization tool. We do it for Kubernetes. So for cloud native application, there's a lot of reason behind it, but mostly because it allows for a lot of automation into it. So I would say the difference between Cast AI and other cloud optimization tool is the following. We, in 30 seconds, we can tell you how much you currently spend on your cloud native application, whether it's EKS, that's Amazon, GKE for Google, AKS for Azure, or even the open source version. So COPS in particular. So in 30 seconds, we'll tell you how much you currently spend. And then we'll also tell you how much you should really spend. Really spend in the sense of, is there any right sizing opportunity? Are you using the right type of instances? Can we optimize by switching to spot instance or reducing the number of CPU that you use because you may not need that much? So that's what you get in 30 seconds. We call that the savings plan or savings report. And then a minute later, there's this button on the top right corner. You click on this and it automatically will reduce your cost to the amount that you would have seen in the savings report. So Cast AI is all about that automation. We have an AI engine that understands very, very well what is the requirement that your application have in terms of CPU and memory on one side. Then we'll tell you what the AI engine would do if it was in charge of managing that Kubernetes application on the right side. And then the click of the button would realize this cost, and it would take a few minutes.
I've got two follow-up questions there. I'm going to ask the second one first because I think it's probably the simpler answer. So you're implying there that clicking that button will mean it will talk to EKS, Kubernetes, whatever, and just apply those suggestions. Basically.
Exactly it. Yeah.
Okay. Could you roll it back again as well? If you
of course.
Okay.
The engine means that whatever the engine feel is more appropriate or more cost effective to run your app will effectively be the cluster, the Kubernetes cluster you will get after you fully onboard that application. We call this rebalancing. And then from that moment, you're optimized. So your cost is optimized. You only spend what you need, nothing less, but also nothing more. And then you will stay in the optimized state. We replace the autoscaler up and autoscaler down from EKS, GKE, or AKS, but by something that is a lot smarter in how your cluster will, expand or shrink over time.
And the other question is, so you say 30 seconds, which is very impressive, but the initial question that jumps into my mind is, clusters experience spikes and patterns in usage that could take place over periods of days or even a week or so. So how do you factor in things like that so you don't, downscale to something that then is too small in 3 days' time, for example?
Oh, that's a great question. You should think of us as a real-time engine. So at any time, the engine will constantly ask itself, am I optimized? Am I in the optimized state? Yes or no? So the engine will effectively manage your autoscaler in real time, right? Every few seconds, it's going to restart the whole process to say, am I in the right place? Am I happy in what I'm using? Yes or no? And if the answer is no, then it will add immediately the node that is required for the amount of workload that you have, or it will do the opposite. It will reduce the infrastructure you use if the workload has disappeared or is reducing. Let's say it's night and you have less users in your application. Therefore, there's no need to keep the same infrastructure as you have during the day. And so it will all do all of this by itself as part of the magic. And then typically users of Cast AI will see an instant cost reduction that goes between 50 and 75%. We even have a customer that had a 92% cost reduction. And it's not so much because we use spot instance, for example. Yes, we do use spot instance. We use all the strategies that you can on all the hyperscaler, but it's because we have a very, very smart right sizer. So we can understand quickly what is the amount of waste that the application may have, and we automatically immediately reduce that waste. And that's, I would say, probably half of the story come from there. The other half being the smarter selection of machines, including spot instance, if necessary.
So I guess the all-important question with something like this that offers to save you money is, how do you determine what you charge people and to make that worthwhile?
That's also a great question. It's a platform fee. And so there's a platform fee and there is a utilization. So it's a few dollar per month per CPU. The price is actually on our website. So we are very transparent about it.
I saw it. I was just sort of meaning in terms of, the offset.
Oh, yeah. The way we price this is that you have a return of investment anywhere between 5 and 10. So you pay Cast 1, you will save 5 or 10, depending on how big your cluster is. We have a customer where his return is, her return is 23 times. So it all depends how, the situation you have. But yes, it's a cost saving tool. So it's priced the right way where you otherwise what would you use it, right? So you always benefit from it. That's the idea.
I always wonder when I've seen platforms and tools like Cast AI, is there ever any pushback from the cloud providers? Because, you're...
That's a great question too. So, no, there is not. And we speak to, I think, all of them. And here is why. So you see, what do we do really is we give a lot of confidence for the user that what they spend is the right amount. And it's very visual, right? There is a report that shows that to you. You have the current one, you have the target optimization, you know exactly where you go before you do it and as you're doing it. It's very, very transparent in what it does. And so essentially it makes the customer very confident and happy that it's using the cloud for what it should. And it also uses the entire flexibility of the cloud. Right? When we shift instances from one type to another because it happens to be more cost efficient to do so, then the customer will see this and will feel, oh, I understand now why it's doing this and what is my impact. So for the cloud provider, it's the same thing. Would you have customer that feel they overpay, or would you have happy customer that feel that they are only spending what they should spend? And then I'll tell you the secret is, every time, and this has been consistent with all our customers, every time we turn this on, customers tend to use a lot more of it than before. Why? Well, because imagine this, we find 60% of your cloud cost as new budget. So what happened there? Well, let's do the project that we couldn't do before, right? Let's go to another availability zone, another region. And that's always what happens. You see, it's the same as when you make something become a commodity, a hot commodity, then you end up having a lot more utilization than before. That's the impact we have. And this is consistent. Yes, there is a short-term drop, but of course, and the hyperscaler may feel it, and there is a short-term pain in this case for them, but they will see in a month or two it's back up because, it's easy and simple.
I hope you enjoyed the show. Went a bit long, Had quite a lot of interviews there, quite a lot of information. You can find out more about me at chrischinchilla.com, where you can find show notes, sign up for my newsletter, find my writing and other videos and streams. There's also details there of how you can get in touch with me. And if you want to get even closer to what I do, join my Discord server for behind-the-scenes discussions and help me produce my shows and work. You can also find details of how to support the show through a contribution, through a donation, or through merchandise. I'll see you next week with a more normal show. Until then, take care, everybody.